Thanks for checking out this video. What we are going to look at today is the analysis of a large fitness testing data set. So on the sheet called database, we have a large set of information for a group of athletes across two teams, and as you can see, there's plenty of different metrics that have been collected. One way you could do that would be using a pivot table. Pivot tables are a very quick way to get ad hoc analysis done and to, for example, find out the maximum score for a particular test for a large group of athletes all at once. However, using formula gives you a little bit more flexibility if you are trying to prepare a custom report. The video is going to be broken into two pieces. The first piece will be doing analysis formulas such as count, average, max and min, trying to extract out using criteria a particular score. So for example, to extract the best result on the yo-yo test since a particular date. I've already pre-populated the formulas and I've written them in blue, and I'm going to leave them there. We're going to repeat them as a live formula. At the moment the formula works, but I've just put a space in front of it. So for example, if I take that space away up in the formula bar and hit enter, we can see that the formula actually works. So you can have that as a reference if you're trying to do these examples yourself. On the right hand side of the screen, there are some website links and YouTube video links where there might be a little bit more detail around, for example, the aggregate function, which is a large part of this tutorial. The aggregate function has about 25 different scenarios that you could go through, so we're only going to look at a few. If you're interested in the rest, then those videos would be the place to go. Alright, let's get started. When you're making formula, it's a really good idea to make them dynamic. So rather than hard coding information into a formula, you connect it to the contents of a cell. And in the case of names, that cell is a drop-down list. In the case of position, that's also a drop-down list. In the case of these dates, it's just something that you would manually enter, so you could change that to a different month and the formula would update. So that's what those gold boxes denote. Just want to quickly go back to the database sheet. If I click inside any cell, you can see that there's a little custom toolbar appear called Table Tools, and that tells us that this has been converted to a table format. When I click on the design option, it tells us that the table name is TBL data, so that's useful. When we go back to our formula sheet and start writing formulas, we've got that clear. If I want to do any type of count, I simply type equals and then count, and we can see that there's about 8 options there that we could choose from. The one we want is called COIUNTIFS, and we now have to plug in two different parameters to the formula. So the first one is to say what range should the formula look in. If we're trying to count names, then we need to look in the name column. Table referencing is great for formula because it makes it pretty easy to understand. Simply with my mouse click on A7 and I can now see that there's a blue box around it, which is quite helpful, good for auditing. Tells us that we are counting the amount of times Billy Josephs appears in the name column of the data table, and it's going to tell us 16. If we wanted to add a second criteria, we can do so. This time we need to do COIUNTIFS because there are two criteria, and we just have to list them one after the other. Just like previously, we start with name, and then we just put in the second criteria. So firstly, we reference the correct column of the table, which in this case is date, and now we just have to put our criteria in. This part is a little bit tricky, and that is because we are wanting to click on a cell and have that cell be live inside the formula. We need to put our mathematical operators inside brackets. That's how we do that. So we put quotes around our greater than or equal to. Then we do an ampersand to join it up to the cell where our date is entered. That's because in a formula like this, Excel is expecting a number. And when you start typing text in there, and so that greater than sign is a text character, Excel gets confused. So putting it inside quotes makes it clear that it's not a number, and it should join it up to our date, and it can do the calculation just fine. So we've got two criteria, and we can expand that out even further with a third criteria if we wanted to see between two dates, like so. Let's do this all out the long way. First criteria is name, and that connects back to A7. Second criteria is date. And that's locked into cell L7. Third criteria is also date. And that's locked into L8. And so what we can see is that we've got a criteria for name, we've got a criteria for start date, and a criteria for end date. If it meets all of those three criteria, then it's going to be counted. And so it comes up as 4. And if we change that to a different date, we should see it update. And so now that's going to be live, and it's going to adjust whenever we change our inputs. So that's those gold cells. Now you can apply the same logic to different types of filtering, if you like. So we looked at player name, but you could do it for a particular team. You could do it for a selected position group, and so on. That's what these other two, rows 10, 11, and 12, run through examples for that. So let's just do the COIUNTIFS for team. We don't have to run through everything because the formula are there. You can try them out yourself. What is our criteria? We have to choose the right column. If we're trying to filter by team, then we obviously need to choose team as our filter. Then click on what the actual criteria is. So it's exactly the same as the previous example. The task is really just to repeat over and over the process of aligning your criteria column with your criteria. And so there we are, we've got formulas working. Let's do this one as well before we move on to average, max, and min. So if this time we're looking for position, then unsurprisingly, we need to choose position. And then connect to the cell where our position has been selected. And it's getting a little bit repetitive now, but that's a good way to reinforce it. Critical aspect of this formula is that you get the quotes in for your date connected ranges. That's one thing that will likely trip you up if you are rushing through when you're new to this type of thing. What's really common is that you would want to find out the average for an athlete to see if today's result is better than their average result, or to see if today's result is better than the average result for a team or a position group. So this stuff is a little bit more real now, and just like count, average also has an average if and average ifs option. So let's have a look. First one, single criteria, average if. Let's start easy. What we are looking for is the criteria column first, and so obviously that's name, and we can connect it up to the cell where the name has been selected, which is A21. But there is now a third variable inside this formula, And what it's asking us is that once we know the rows where this athlete has been selected, what do you want us to do? What do you want us to average? It has to be a numeric range that we average. You can't do an average of text. So we have to give it the correct average range so that it can do its calculation. We could choose anything here. I've just chosen body weight for this first example. So the AverageIf formula just has that third measure that you need to plug in. Otherwise, the concept is the same. I just changed the format there. Next, let's look at a double, and then we'll do a triple criteria as well. So, same example as before, looking at body weight since a specific date. What you'll notice if you read the formula tips is that it's rearranged the sequence of criteria so you can get caught out by this. Because there's multiple criteria, it wants you to specify the average range first. So what are we wanting to get the average of? In this case, it is body weight. So it is a little bit confusing that it flips that around. Before it was the third parameter, now it's the first one. After that, we put in our criteria, as many as we've got. Start with name. But once we get going, we realize that it's the same syntax and the same process to the one that we used above for counts. So there it is there, we've got an AverageIf with double criteria. So we could repeat that exactly same process if we, like we did above, have two date columns. But what is an interesting little tangent is that you might want to flip things a bit and say, what's their average for the past 12 months? And to know that, you need to either specify the start date of their average, and then it simply becomes a replica of the previous example. But if you don't want to have to continually update that, you might need to plug in something else. And a formula that you might plug in is called today. I'm doing this on the 2nd of August 2017. And if I wanted to know what today was, I could simply type today, open close brackets and hit enter, and it would tell me that. I could also be wanting more detail, and I could type now. And that would not only tell me that, but it would also tell me the time. So the date and time. I'm just formatting it to show time only, but we can see that it's 9:20 in the morning. So those two formulas can be useful in that they can provide, every time you are working in the spreadsheet, today's date so that a formula could reference it. So in my example here, if I click on cell L21, we can see that I've taken today and I've minused off 365 days to find out what is the date a year ago. That then plugs into the formula and gives us what we're looking for, and it's going to update consistently. So every day that you use it, the today formula updates, and the criteria also updates, which then changes the outcome of the formula too. So it is a nice little operation there. But a little word of warning is that if you're using a lot of these formulas like today, it can cause your spreadsheet to slow down a little bit because that formula is volatile. A volatile formula is one that is constantly recalculating, especially this now one. So if I hit it again, you can see it's updated again. So it's constantly rechecking to see whether it's right, and that requires resources from your computer. So just a word of warning there. It's unlikely that you'd have a lot of those formula in there, but every once in a while you come across a spreadsheet that is going a bit slow that contains a few volatile formula. So a repeated situation for averaging team averaging for a team since a given date, you can see what those formulas look like and you can give them a go yourself. Where it starts getting tricky is when you're trying to find the best score with criteria. Now, in the world of sports science and fitness, the best score can mean two things. It could be the largest or it could be the smallest, depending on the test. So speed and things like that have low scores, whereas strength tests and so on have high scores. So it's not always a consistent formula that you're going to need. You're going to need to understand your data a little bit so that you can choose what you want. If you're using Excel 2016, you've got a couple more options than if you're not. A formula was introduced that is called MAXIFS, and MAXIFS allows you to do exactly what it suggests. It's like AverageIfs and COIUNTIFS and SUMIFS. It is telling you that with certain criteria, what is the best score. Let's have a look at it. I'm going to put it underneath here. Inserting a row might be sensible. Let's go through these three examples. So you can see here the tooltip is telling us returns the maximum value among cells specified by a given set of conditions or criteria. So we can do multiple criteria as long as we have that consistent data entry. So what is the max range? Let's look at yo-yo distance. Now what is our criteria? It's pretty easy. First up, we just want to look at it for a selected athlete. And so we chose MAXIFS, but we only did one criteria. Excel's not going to melt down over that. That's okay. So if I hit enter, it's going to tell us that for Anita, her maximum score is a whopping 2440. And so MAXIFS works great for that. If you're not using 2016 version of Excel, it's a lot more challenging. You have to do what's called an array calculation. Now, it doesn't have to be scary, but it can seem like it is. So let's start with max. Inside the brackets, we type an if function. And we haven't covered them in this video, but if you want to learn more about it, there'll be plenty of things out there that you can follow, lots of good YouTube videos and things like that. So what we're asking is that if a certain test is true, and that test is if our name equals A36, then we want to include the yo-yo distance results. Otherwise, we don't want to include anything, and so we can just close the brackets off. Very important step here. If you're not familiar with array formulas are a special category of formula that can do multiple calculations inside one row, and to make an array formula, you have to hold down Control and Shift when you press enter. And if you look in the formula bar, you'll see that there are curly brackets around the outside of the formula. I didn't type them in, Excel put them in because that indicates this is an array. Gives us the same answer, so that's good. The formula I really want you to learn and get familiar with is called aggregate. Aggregate is this mega function, and as you can see, as soon as I type it and open the brackets, I get this whole menu, and there are 19 options within it. So there's 19 different formula that you can replicate using aggregate. And we can see max and min at the top, and don't be fooled by that. We don't want to use those. We want to use large and small, because large and small are capable of handling large arrays of data and for us to put criteria in. So that's what we want. In this case, we've got yo-yo distance, so we know that a large number is good, so we're going to choose large. And this is where it gets further complex. It only puts the index number of that formula. It doesn't say large. I think that's a mistake. They should be making that say large. I would be doing that if I was programming Excel, because saying 14 doesn't exactly help you understand what's going on. It gets more complex because when I hit the comma, it gives us another list of options, all of which sound like they could be a good idea. Just trust me on this one, and I don't have any circumstances where I haven't used option 6 there to ignore errors. So 14.6 says that we want to find the largest and ignore all errors. Now we can get into the real formula. We need to specify what we are looking to do. We're trying to find the highest yo-yo distance. And to put criteria in, we simply do a divide by. Inside brackets, I'm going to put my criteria, which is that the name of the selected athlete must equal 836. Close that bracket off. That's our array. And if I select inside this piece here and hit F9, we can see that there's a whole sea of errors with just a few numbers in there. And so what the formula will do is ignore all those errors, because that's what option 6 asked us about, and it'll just do the numbers that exist and find the best one of those. So F9 and Control Z allows you to step into the formula and see what's going on. The last little part is that we have to say, what do we want? If I put 1 down, that's going to give us the largest. If I put 2 down, that's going to give us the second largest. 3 would give us the third largest, and so on. So that's what the last variable called K means. And so as we can see, all 3 of those options gave us the same score, thankfully. And so we could use all of them. Aggregate would be my recommendation to you. Now, if we wanted to do a dual criteria, then the aggregate formula will do exactly that without much modification. So I'm going to copy that final formula that we did, paste it in, and make some modifications to it. Just going to backspace a little bit and get rid of that last variable. So we've put a single criteria in. If we want to put another criteria in, we just replicate what we did. This one wants to be a date. It needs to be greater than or equal to that. Because we've got 2 criteria, we need to wrap all of them in a set of brackets. So just put an extra bracket on the end and an extra bracket in the beginning, just to join those 2 criteria together. Now we just put our 1 at the end, and there's our answer. So it's a little bit different to the answer we got before, because our second criteria is clearly screened out that score of 2440. Now, if we wanted to do a third criteria, then it really just is an extension of our example. Let's copy that. Let's paste it over here and go through the process. Just going to backspace that away. I'm going to put another criteria in. It's leveraging off date. And this time we want it to be less than or equal to this cell here. Put the extra bracket on the end and we're good to go. I just want to rearrange this for completeness because that was linked to the incorrect cell, but I think you get the picture. We have all of our 3 parameters linked with color boxes. So we've got the name over in A36 highlighted blue. We've got N36 and N37 highlighted in sort of burgundy and purple respectively, because they're our 3 criteria. And if I just put our 1 on the end and then hit enter, it's going to give that calculation there. So in this case, I've just leveraged it off yo-yo distance, whereas up on the right here I've talked about 10 meter speed. So I need to go and correct that. How would I do that? Well, for a start, if we look at right at the beginning, we have to put a different index number in because a speed test requires the smallest score. So I'm going to change that from 14 to 15. That's what I don't like about those index numbers. It doesn't immediately jump out at you that that's small and the other one is large. Instead of yo-yo distance, we choose speed 10 meters. And so here we are, we get our speed score. Now you occasionally get problems with scores like this. If a 0 is in your database, for example, if they didn't test 10 meter speed or you didn't get a time for them, then you can get problems because this will always come up as 0. If you wanted to do a little bit of error prevention, you could put another criteria in there. So I'm just going to do that and I'll explain to you what I'm doing and why. So my criteria will be that it must be above 0 to be included in this analysis. So I'm just adding a criteria really. So you might say greater than 0.1 just to be safe. And so now it's only going to be able to include speed results that have a score that's an actual number, so not a blank or a 0, and that it has to be a sensible score as well. So if there's for some reason a random number in there, it's not going to include it in there. Let's put a 1 on the end and go enter. In this case it hasn't changed anything, but if we had a 0 in the data set for a few athletes or all athletes because of just the way that your speed timing system works or something like that, then that's a way to prevent that error. And preventing errors is very helpful when you're processing lots of data and trying to do reports nice and quick. So the same aggregate formula would be used for extracting on the basis of team, on the basis of position and so on. So there's plenty to take in. The aggregate formula is incredibly powerful, it's fast, it allows you to have multiple criteria in place, and if you're creating a dynamic report that has references to a wide variety of options, or that you want to allow the user to be able to select the reference point, so for example plotting data for an athlete and allowing the user to choose whether you want to compare it to team average, position average, or a time-based position or team average, then you can do so very quickly by having a little aggregate formula in place. So it's definitely what I would recommend you use rather than the max array formula or even the new built-in MAXIFS formula, because at the moment it's still not consistent that everyone can use that formula. So I wouldn't send a spreadsheet to someone that has a 2016 only formula in it. So thanks for stopping by. This video will continue. What I want to do is take you through the scenario where we extract information. We've done that before, but I just want to tie it together with our current example. So we've found out that the position best for the box squat is a certain amount, but what if we want to know who that was and when it was recorded? The only way you can do that is by extracting information using what we've gained from the aggregate function. So that's in the next video. Hopefully I'll get that out in the next few days.